Let's work with the properties of logarithms. For example, given that log x is 3 and log y is -2, let's find the log of x to the 5th y cubed and the log of x squared divided by square root of y. And we'll be using the following properties of logs to help us, where here a is any positive base not equal to 1, m and n are positive numbers, and p is any number. So let's begin with the log of x to the 5th y cubed. By this property down here, the logarithm of a product is the sum of the logs. In other words, this is equal to log of x to the 5th plus log of y cubed. And by this last property down here, the logarithm of a power, we can take this power and bring it down in front of the logs. So let's do that to both of these logarithm expressions here. We can bring the 5 down in front here, as well as the 3 down in front here, which gives us 5 times log of x plus 3 times log of y. Now we're given that log x is equal to 3, which we can plug in here, as well as that log y is -2, which we can plug in here. Therefore, this is equal to 5 times 3 plus 3 times -2, or 15 minus 6, which is 9. All right, and what about this last log we're asked to find? The log of x squared divided by the square root of y. Well, by the second property over here, the logarithm of a quotient is equal to the difference in the logarithms. That is, this is equal to log of x squared minus log of the square root of y, which is equal to log of x squared, and then minus log, and we can rewrite square root of y as y to the 1/2 power. We wanted to write both of these expressions with powers so that we can bring these powers down in front of the log by this logarithm of a power property down here. That is, this is equal to 2 times log of x minus 1/2 times log of y. Again, we can use the fact that log x is equal to 3 and that log y is equal to -2, which gives us 2 times 3 minus 1/2 times -2, or 6 plus 1, which is equal to 7, which is our answer. All right, let's look at another example. Let's compute log base 2 of 24 minus log base 2 of 3. Now, do we know a power that we can raise 2 to get 24, or a power we can raise 2 to get 3? We don't. So we could use the change of base formula on each of these logs separately, but it's going to be much easier if we use these properties of logs. If we look here at this middle property, we can use it in the reverse direction. In other words, we're starting with this, and then we're going to condense it using this property. That is, this is equal to log base 2 of 24 divided by 3, which is equal to log base 2 of 8, which is equal to 3. Since converting to exponential form, we know that 2 cubed is equal to 8. So this would be our answer. And this is how we work with properties of logs. Thank you, and we'll see you next time.